Hi everybody, it's Miss Moran, and I wanted to show you what the standard of work looks like in the second 9 weeks for our science labs. So at the beginning of the year we were doing a whole lot of different things, getting used to the science process skills, learning about science tools, getting ready for STEM fair. But in these last few weeks we've been working on energy labs and energy of different forms, and I want to show you what high quality A-level work looks like in the second 9 weeks. Grades are being given on a check plus, or check minus scale. Check being an average standard, check plus being going above and beyond to make sure work is organized and presented logically and includes correct scientific explanation, and check minus means it's missing some things or has some inaccuracies. Our first lab was on speed, a way to measure motion. Data part 1 was that we included our running speed and a time for that, or running distance of 30 meters, a time for that, and then a division to calculate the speed of distance divided by time. Then we applied that to toy cars, and we had a distance, a time, and a speed as well for number of cars. The conclusion includes an explanation that in order to calculate speed, we're going to need a stopwatch for the time, a meter stick for the distance, and distance divided by time on a calculator. All right, our next lab was on light, a form of energy, and we started off with a few descriptions about what happens and how light travels in all directions away from the source, and if light's path is blocked, light will not turn or bend, and will cast out a shadow behind the object that's blocking the light. Then we learned about light in the form of color and how light is made up of the color bands red, orange, yellow, green, blue, indigo, and violet. We had little refraction peepholes that would show us the light broken up into those colors. We know that energy is any process that can cause change, and light can change from darkness to the ability to see, and also can produce color. Our next lab was on potential and kinetic energy. So in this lab we explored how changing the potential energy by increasing the force or the ability to the force to be applied by changing the height or the condition of a object would cause greater kinetic energy. So this was dropping a ball from different heights and then the height of the return bounce. So as the ball is raised higher off the ground, the return bounce also becomes greater. Then we gave a ramp, and as we changed the angle and the height of the ramp off the ground, we also changed the amount of roll that the ball had coming off of a ramp. Then we explained how in order to increase kinetic energy, you have to increase the potential energy. Our next lab was on heat energy and conduction of thermal energy. We heated water in a pot by using electricity to heat a burner. The burner heats the pot heats the water heats the other water particles. And then we put some items into a pot, a few different kitchen utensils, and we noticed that the metal spoon was hottest at the tip because the heat energy could travel through it, whereas things like wood and plastic blocked the heat energy and were cool at the tip. We took 2 cups, one was a plastic cup and one was a foam cup with water of the same temperature. When we touch the outside of the cup, the foam cup feels coolest because it is blocking the heat from traveling through it. But if we put our finger inside of the cup, the water that's in the foam cup felt much warmer because that water was retained in the heat. The heat was retained in the cup throughout the duration of the experiment. We learned that a good conductor of heat is metal. Our next lab was on electrical energy, and we worked with circuits. We needed batteries, wires, and bulbs and metal conductors in order to light simple light bulbs. We drew a picture of what a closed circuit looks like and explained that it was closed because everything was connected and the bulb was on. We also had an open circuit, which was an opening or a disconnect in the path, and an off light bulb. Electricity is a form of energy because it can cause a change by powering devices on or off. And we talked about metal conductors and batteries being needed to power electrical devices. Our last lab was on properties of sound energy. We were looking at how we could change pitch and intensity by changing the vibration of objects. Our first data activity was on pitch and how we could change the length of a vibrating object to change the pitch. So a smaller vibrating object is going to produce a much higher pitch, whereas a longer vibrating object produces a lower pitch. So we learned about how pitch is determined by the speed of the vibrations, whereas when we use less or more energy, we weren't affecting the pitch, we were affecting the intensity or the volume of the sound. So less energy produces a quiet sound, more energy would produce a louder sound. We drew some pictures of sound waves. And then we had our own simple stringed instrument, sort of a makeshift guitar in the class. And we wanted to learn that using a small vibrating object, like pinching down the string on our guitar, would cause for a high pitch, whereas if we allowed the entire thing to vibrate, it would produce a low pitch. And plucking harder or softer would make for a louder or softer sound. Okay, so this is the expectation of what science labs should look like if we're looking for A, quality work. Making sure that everything is neat and well organized. A lot of students have pages out of order, big gaps or spaces in their work. Skip a page here. You start a sentence and don't finish it, or it's incomplete because you were enjoying playing with some of the science materials rather than writing some of these details here. All right, so you can take a look at your science notebook and compare it to what you see here, and use that to make some improvements in your work going forward. All right, thank you for taking the time to watch this video.